Today we have extra practice with writing equations in slope-intercept form when given the slope and the y-intercept, or given some points, or given a story that gives you that information. This is all independent practice, but I'll go through a couple of these as examples and reminders. For better examples and more thorough explanation, remember to go back to the previous 2 days where we had full videos on those. So looking here, just to get started, we have a slope of 7. Remember, we called our slope m, so m is 7. And our y-intercept is 4, so b equals 4. And our standard form of linear equations is y equals m times x plus b. So here that would be y equals 7x plus 4. Pretty straightforward. We're given exactly the things that we need to plug into the equation. Then we have a couple of stories. Here the key is identifying which thing is the y-intercept and which thing is the slope. So here we get a $500 signing bonus. That only happens one time. It's a bonus, not a recurring thing. So this $500 is our y-intercept. He makes $200 per day. So the number of days, that's variable. If he works 1 day, he makes $200. If he works 10 days, he'll make $2,000. So the number of days is variable, and then this is how much he makes per day. That would be our slope. So when we're looking at word problems, the key is identifying between the two numbers given, which one is going with the variable and which one is our constant, that's our offset or our y-intercept. So I'll let you figure the second one on your own, and then I'll let you figure that on these as well. So this is the same as those other stories. You're looking for what is the b value and the m value to write the slope-intercept form equation, and then you'll use that equation to do the graph. And we'll have some more practice with graphing further down, so I will touch on how to do those if you don't recall from the previous lesson. Here again we have slope and a point, so we're going to have to find the y-intercept before we can graph. We looked at that yesterday as well. We identified our slope, and then we said that since this point lies on the graph, this must be a valid x-y combination that makes our equation true. So we write our equation y equals mx plus b, and we plug in all of the things that we know about. So we know the slope is always going to be minus 2, and we know that when x is 5, y is going to be 3. So we can plug these two in together, and we can find out that our equation is 3, that's our y value, equals negative 2, that's our slope, times x, that's 5, plus whatever b is. They didn't tell us the y-intercept, so that we have to solve for. It's pretty straightforward to do. We multiply these two together. Since they're both constants, we can combine them, and we get 3 equals negative 10 plus b. And then we add 10 to both sides to come up with b equals 13. Then we can write our entire equation in general form without a specific y and x. Our slope was negative 2, so negative 2x, and our offset is 13, so plus 13. And then from there, you'll graph that. Again, we'll do some graphing a little bit further down, so I'll let you look at that further on if you need it. We have some more similar examples. I don't think there's anything else in this page that is particularly new or different than those earlier problems. It's just more practice because we really need to get these ideas down about how to do linear equations. So work through these practice, get used to how they work, and then we'll look at this other sheet we have today, which is graphing linear equations. Whenever we have a graph, our key things that we want to know are the slope, because that's our rise over run that changes from step to step, and our y-intercept, because that gives us a point to start from. Looking at our equation here, we already are in slope-intercept form, and we know that this 1/2 is our slope because it's in front of the x. And this negative 6, make sure we keep the negative here, is our y-intercept. So since our normal form is plus b, we're adding -6, right? So that -6 is telling us our y-intercept is down here, not up here. So let's place our y-intercept. When we intercept the y-axis, that means we're on this middle line here, and that means we have a point at 0, -6. That is our y-intercept. X equals 0, and then we go down 1, 2, 3, 4, 5, 6 to find our y-intercept right there at 0, -6. Then we use our slope, remembering that we have rise over run. We have a rise of +1, so we go up 1 space. And then we have a run of +2. Our run is always positive, so we go up 1 and right 2 to find a point right here. Once we have 2 points, we're going to use a straight edge like a ruler or an ID or something to connect them, and we're going to draw a line between them with an arrow at both ends, meaning it goes on forever both directions. So that's how we're going to do our graphs. We need those 2 key values, M and B, before we're able to graph it. I want to look at number 5 real quick because that's something I don't think we've seen yet. We have y equals -2x, and then there's a piece missing. So we need to think of that missing piece as being +0, right? So that means our y-intercept, it's not that it doesn't exist, it's just at 0, 0. Our y-intercept b is at 0. Our slope is just -2, like we're used to. So if we wanted to graph that, we need to put our y-intercept at 0. That's the origin right here at the middle. And then our slope is -2, which remember is -2 over 1. So we have a rise of -2. So instead of going up, we're going down 2 spaces. And then a run of 1 always to the right. So we go right there. So this tells us we go down and to the right. And remember, I mentioned before, we can also reverse that. So if I wanted to find, instead of the next point in order, so I could go down 2 over 1, down 2 over 1. If I wanted to find a previous point, I can reverse both of those directions. Instead of down and right, I could go up and left. I could go up to left 1 and continue to find points up here. And then once we found 2 points, we just draw our line through them with the arrows at the end. Again, please use a straight edge, make it straighter than this. And that's how we do graphing. So we have a few more practice with identifying slope and y-intercept. For these, the key is we have to rearrange them. We need y by itself on one side. Let's go through one of these as an example. We'll just do the first one. So in order to get y by itself, our first algebra step would be to move this -x and make it go to the other side. So when we move it to the other side, it becomes a +x, and we have 2y equals, I'll put the x in front for slope-intercept form, x plus 12. And then we can't have a coefficient in front of y, so we divide, again, every single term. We divide the y's, the x's, and the constants all by 2 to come up with y equals 1. I'm going to write this as 1/2 x. Just so that it looks like slope-intercept form. That's the same as x over 2. And then plus 12 over 2 simplifies to 6. If you write x over 2, that's okay. I just like 1/2 times x because that lets me really clearly see my slope is 1 rise and 2 run. And I can do that because 1 times x, this is the same as x over 2. All right, so then there's some more practice with rearranging these. These are more practice with the rearranging and then also graphing the line. So nothing that we haven't already looked at, just combining those 2 different things that we just went through. Rearranging, identifying M and B, and then placing that onto a graph. So that's your extra practice for today. There's a lot of problems, but we really need to work on this one to get our skills down. These are critical skills for what we do throughout the year in algebra. So be sure and do all these practice ones and get it figured out.